Thanks for joining us today, and we're going to be talking about our profile nest module. And initially, what we want to talk about is we have a nest module in our available list of plugins, but we also have a profile nest module. So what's the difference? Just mainly, the nesting module will nest your geometry. The profile nest module will nest profiling operations. Okay, so each part you will set it up as a to program a 2.5 axis profiling operation, and then when you set up your nest, you're actually your initial part will stay where it's at, and then your profile operation is what will be nested. And
Don, we lost you again. I think you're muted again.
I'm not sure how that happened. Sorry about that. So we talked about what nesting is in relation to our nest module versus the profile nest module, and we're going to be talking about 2.5 axis operations in this webinar. So I recommend that you go back after we're done here and look at the last two webinars that we did. We did an introduction to 2-axis machining and also a more advanced webinar on 2.5 axis machining. So that would be a good idea to go and look at as well as this webinar here. So what we got here is just an example of the types of tools that you might use in 2.5 axis machining. We got a flat mill, a ball mill, a chamfer mill, a V mill, excuse me, and then a chamfer mill. The red X by the ball mill is just an indicator that in most cases the ball mill is not used in 2.5 axis because of the nature of the ball will ride over any control geometry that you select. So you can see that in the waterfall effect that we're showing here down here. And then also the supported tool types and profile nesting, they're listed up here. We have the ball mill, the flat mill, the corner radius mill, or called a bowl mill, a V mill, and we have a chamfer mill, a taper mill, which can have a ball on the end, face mill cutters, dovetail cutters, fillet cutters, lollipop cutters, and then you can also have your custom tool profiles that you can use. Now let's talk a little bit about geometry. The geometry requirements or the use of geometry is exactly the same as in our milling module. You can use just flat 2D drawings, which is what we're going to be using here in this demonstration. But you can also use wireframe drawings. Most cases, you're not going to run into a wireframe drawing anymore. But if you do, you can use those to create a profile nest. And then, of course, you can also use 3D geometry. Poly surfaces, closed poly surfaces typically are solids. And let's talk a little bit about the different types of geometry. So you got your profile geometry we just discussed in the previous slide. That is the geometry that you're going to be creating your 2.5 axis operations on. And then those operations is what's going to be actually nested onto a sheet. So you can actually define your sheet, the size, length, width, thickness of your sheet, those characteristics, and as well as you can give a quantity, but we're going to look about how we can automatically calculate the quantity if you don't know how many sheets it's going to take. And then, of course, the stock model you can define to be the same size as your sheet, so you can actually do cut material simulations as we're showing here on each of your sheets. Now, we're going to talk a little bit about 2.5 axis profiling, like I mentioned before, to really get an in-depth view of 2.5 axis operations, go back and look at the April and May webinar series, and we'll talk a lot in depth on 2.5 axis. But briefly, what we have on the screen here for when you're creating 2.5 axis operations specifically for the profile nest module, you will create, obviously you will have your parts that you're going to nest. And over here on the right, we see the 2.5 axis profiling operation dialog. The cut parameters tab is shown here. We're going to be looking at these parameters in detail in the demo part, but I'll just go over briefly what they are, at least on the cut parameters tab. You can define your global tolerances, your geometry tolerance, or the tolerance that your profiling operation will be in relation to your actual geometry. And then you can obviously define a stock. Stock is defined in the X and the Y. So stock is not defined in the Z depth. That is controlled by the cut levels tab. Then you have the standard cut direction options, climb, conventional, or mixed. And then you have options here to control where the cutting is going to start. You can have it automatically start at the longest side of your geometry, or you can specify how it's going to start. And then also you have side step over control in profile nesting. If you want to do a rough pass first and then do a final pass, you can define those here. If you leave them at 0, 0, just make one pass for your profiling operation. And then you can also perform a cleanup around the corners. And then over here on the right, we have a tab specifically for profile nesting. You can, in this tab, define how many parts that you actually want in the total nest. You can give each part a priority. So priority parts will be machined first, starting from the bottom left corner of the sheet. And you can control the orientation. If you check this box, it'll stay in the orientation that you have it drawn on the screen, and then you have some additional grain direction controls. Now, if we skip over to the left side, you can look at this machining job. What you got here is under operations to nest, you have the 2.5 axis profiling operations that you're actually going to nest. So you program a 2.5 axis profiling operation for each of your parts in your drawing. Then you take those parts and you process them and put them onto sheets. So in this example, we have 3 sheets, and you can see sheet 3 actually lists all of the profiling operations in that sheet. Again, if you got any questions, let us know and we'll get right to them. Now, nesting parameters. There's 2 types of nesting parameters that you can, or that you need to define to create a profile nest. On the left here, we have the sheet definition dialog, where you can create a sheet by entering the dimensions of the sheet and the thickness of the sheet. Or if you have the sheet drawn, rectangular perimeter of the sheet drawn on the screen, you can use the select curves option, and it'll create a sheet from that. And in this example here, we're going to be using sheet dimensions. We'll show you how to actually define the dimensions and locate the sheet. And by default, the sheet will be located at the world coordinate system origin in your CAD file. And then over here on the right, we have a dialog just for your nesting parameters. If you're familiar with our nesting module, you will recognize almost all of these parameters. We don't have all of the same parameters in nesting, but we do have quite a few. You can select the different type of nesting. In rectangular nesting, it just creates a defines a rectangular area around the part and then uses that area to actually do the nesting. And the true shape, it actually computes the actual shape of the profiles and nests them in the part as close as it can based on the parameters that you specify. And then you can nest parts inside of other parts if you have cutouts. Engraving and sign making is something reserved for if you have curves that intersect other curves in your control geometry. You can use this option here to keep those curves together as one profile part. And then obviously you can set the dimensions, how far your profiles are from each other, and how far the profiles are to the outer perimeter of the sheet. And one thing to mention here on the distance part to part, that will be the distance between the toolpath center lines. So the center tip of the tool will be the distance between that profile and then the next profile. And then you can tag, we got some tagging options and options to control how the layout of the sheet is going to be displayed on the screen. And then you have additional options to sort how you want the operations and the nested sheets to be sorted within each sheet. And then obviously you can estimate the number of sheets and execute the nest. And we're also going to be talking a little bit about, and we'll talk about it right here, is that we have a lot of documentation for the profile nest module. We have a quick start guide that you can go through, and you can access all of these resources. If you just pick the online help from the application plugin and go to the Find More Resources, you'll see our resource guide for that plugin. And inside that guide, you'll find the profile nest quick start guide and also the complete reference guide, answer all the questions that you have about profile nesting. And then finally, we'll be talking as we go along, and we'll be recommending some tips and suggestions on how to set up your nest, how to do your geometry, how to do your profiling operations. But we also have additional best practices guides for both 2-axis and 3-axis. I recommend that you go back and look at the best practices in 2.5-axis machining. There's a very popular guide that we've had for a number of years now that we keep updated for 2.5-axis machining, and you can access both of these guides from the resource guide that you can access from the online help, or from any other guide that you happen to have displayed. You can access it from there as well.